Welcome, eighth graders, those of you who are practicing for your HSPT math test that's upcoming in January to help you get into high school. I want to help you today to work on some math problems. I'm going to work on 7 random problems. There's no theme to these problems. They're just 7 random problems that were grabbed from a recent test that one of the students took. Some of the problems have the answers already marked on them, so you might not necessarily work them. Maybe you'll know the answer in advance, but I still want to work through them and encourage you to do the same as I show them to you, and then work them to get the answer, and then maybe I'll be able to give you some insight that you didn't have before into the problem. So let's go. We got 7 problems. We are going to go over to our magic pad and see what we can learn. All right. So this is problem 70 off of a sample test, and you're going to get a lot of problems. You'll get a lot of problems like this, and you're going to get some pictures, and it'll ask you to make the best determination of the one statement that is true, or you know to be true. Now, one of the keys is that they're going to give you a drawing such as this, and they're going to give you a constraint. But as long as certain things are not told to you, you cannot make assumptions about the varying shapes. For example, all you know in this picture is that you have a right angle right here. You do not know, for example, how long any of these sides are because they're not marked. So while it looks like, this side looks bigger than this side, you can't know that this side is actually longer than this side. So this drawing could also look like this. That would be a valid drawing because all you know is that this is a right angle. It doesn't tell you what side is bigger, but you do know a few things about right triangles. And so let's get into the 4 different answers here, and let's see if we can make sense of which ones must be true. So we have, first of all, AB is equal to AC. Well, we can't make that determination because all we know about this triangle, again, is that this is a right angle. We don't know how long BC is or how long AC is. This again could be a triangle that looks like this, or it could be a triangle that has a long AC side and a long BC side. So it can't be A, so we're going to eliminate that one. Now, is measure of angle B greater than angle C? Well, we know that angle C has got to be, since it's a right angle, this is 90 degrees. And we know that this angle here, that angle A and angle B must be less than 90 degrees. That this must be less than 90 degrees. And this one must be less than 90 degrees. Because a triangle only has 180 degrees in it. So if one of these angles were 90 degrees and the other angle wouldn't have any measure. So we know that these 2 angles have to be smaller than that. So the measure of angle B cannot be greater than the measure of angle C. The measure of angle C has to be the greatest angle in this triangle. All right, so let's look at this one. Let's see. Question number C is AB, so that's the length of AB, minus the length of AC is equal to BC. In other words, let's see here. Let's draw that again. And let's see. So AB is this one, AB. So this side, if we just call that side X and we call this side Y and this side Z, what they're saying is X minus Y is equal to Z. Or in other words, let's see, that X, the long side, is equal to the long side, the two short sides added together. See what I did here? I added Y to both sides. And I said, well, they're telling me that this long side is equal to the two short sides added together. Well, that cannot be true, because think about it. The one side of the triangle plus the other side of the triangle, if that were to equal the third side, then the triangle would almost have to look like this. It would look like, I don't know how you draw it, but you could, this side, if you just kind of swung it down like this, well, let me do that in a different color. You kind of swung it down like this. It couldn't be, there's no way that this side plus this side could equal this long side here, because this long side always has to be shorter than these two sides, or you couldn't make a triangle. I don't know if I'm explaining that too well, but this one cannot be, that one just cannot be true. In any triangle, the long side has to be less than the other two sides added together, or you physically couldn't build a triangle. So that means that, given that we've ruled out the other three, we know that this last one, D, must be true. And let's think about that. Well, the measure of angle A plus the measure of angle B, does that equal the measure of angle C? In other words, does this angle here plus this angle here equal 90? Well, it has to be true. And the reason is because all triangles add up to 180 degrees. So if this angle is equal to 90, then the other two together must equal 90 to get us to that 180 degrees. So remember, triangles, wait, let's write this. All angles, or let's say it like this. The sum of the angles of a triangle equals 180 degrees. So again, if this one's 90, the other two added together equals 90. So the measure of angle A plus the measure of angle B must equal the measure of angle C, which is 90. So this one is true. Okay, so let's go. Let's kind of go back to, let's go back to here. What's the next problem we're going to work on is going to be, let's see, whoops, what am I doing? Can I not move these images? Let's see here. Let's go back to here. Oh, I see how we do this. So we're going to grab this and we're going to move angle. Here we go. So now we're going to work on problem number 96. This one can be a little bit tricky. So let's be sure that we understand this more complicated drawing. This problem is a little bit like the last one, except for we have a little bit more going on. So let's see if we can figure out a few things here. Well, first of all, let's look at this image and let's see. This is D. D is this height here of 40. So D is 40 from here. Let's see, from here to here. Right? Well, they already have it drawn for you. So D is equal to 40. Let's just write these things on the side. Well, we know that C is equal to 27. B is equal to 8. So let's look at this. So A, if this here, from here to here, let's look from here to here. Well, we know if it's 40 all the way from here to here, then we know from this top all the way to the bottom is 40, then this must be 32. And let's just noodle this out. So if this is 32 and angle A slants like this, and side A, this A here, this side must be greater than 32. So all we know, let's just write that down. Let's just write down that A is greater than 32 because we know it has to be because it slants all the way up here and this piece goes straight up to here. So we got a number of sides here just written down off the bat. So let's see if we can rule out some things right away and then figure out what must be true by ruling out the easy ones. So let's see. Line segment A is shorter than line segment D. Well, that's probably true, which is longer. So D is longer than C. Well, that's true. This here might be true. I'm not sure about this line segment A being shorter than D. Maybe it's longer. We don't really know, but let's come back to that one. So let's look at B. So line segment B is shorter than line segment A. Yeah, that's true. This B is definitely shorter than A. And is A longer than line segment D? Okay, well, we don't really know. Again, is A longer or shorter than D? We don't really know that. So we're not really sure about B either. So let's look at C. Let's see if we can rule this one out. Line segment C is longer than line segment D. Well, no, that's not true. C is 27 and D is, so that's not true. So that one's not true. And line segment B plus line segment C, so 8 plus 27, right? B is 8. 8 plus 27 equals the length of line segment D. Well, no, 35 equals 40. That's not true. So this one's not true. Let's undo all that, and then let's just scratch this one out, and we'll scratch this one out. So let's come back to this first one and see if we can make sense of it. We know that it's got to be A or B. So let's look. Line segment B is shorter than line segment A. So we know that's true, right? B is shorter than A. Now we got to determine if A is longer than D. Or we could look at letter A and say line segment A is shorter than line segment D. We know that, and then we know that that's true. So A is, no, we don't know that that one's true, but D is longer than C. So on this one, we have to figure out is A shorter than D? Question mark. And here we know that B is shorter than A, and then we got to figure out if A is longer than D. Question mark. So pretty much we're trying to figure out which one's longer. Is A longer or D longer? And if we can figure that one out, then we know which one of these must be true. Okay, so how are we going to do that? Well, we see that this is in the middle here. So we're going to have to do a little geometry. And I'm going to just draw, well, let me draw this better. Let me draw this better than that. Let me just draw this line here and draw this line here. And so we know that this is a right angle. So we're going to get a little bit of hint here as to how to answer this problem by drawing that line in. So let's look at this. This is 32. And this here is going to be 13.5. Uh-oh, this is going to be a little bit ugly. But we're going to have to figure out how long is this side A if we have a Pythagorean, using our Pythagorean theorem. So in a right triangle, we can look at the relationship between the two short sides and a long side. So in that relationship looks like this: a squared plus b squared equals c squared. Okay, so we need to say, well, and so this here, and this here being a, and this here being b, and this here being c, the hypotenuse. So we need to say is 13.5 squared plus 32 squared, and then we're going to figure out, well, that's going to be our c squared. So 13.5 squared. Uh-oh, we got to do some multiplication. Well, let's see. That's going to be, well, we know. Let me just do this a quick and dirty way by estimation, and let's see if we can solve this one quicker. So let's just say that let's just let that be 14. We're gonna pretend that a is 14 instead of 13.5, and we're gonna say that that's 196. So we're gonna pretend that this is 14 squared. 14 squared is 196. 32 squared is, well, I don't know that one off the top of my head. So I'm gonna have to multiply this one out and get, let's see, 64. Now that's a 6, and that's a 9, and that's a 4, 2, 1024. So 1024, 1024, and 196 is 110. Whoops. Carrier 1, 2, 2. Okay, so that looks right to me. So now we have to find the square root of 1220, and so let's look at this a different way. Let's see. Well, what would it be if 40? What would 40 squared be? So is this? So the question is this more or less than 40 squared? Well, 40 squared equals 1600. So we know that 1220 is less than 40 squared. So we know that C is less than 40. Because we know, again, C squared is 1220. So C is equal to the square root of 1220. And we know that that has got to be less than 40 squared. So we know here that this is less than this. So we know that A is less than D. So line segment, let's see. So line segment B is shorter than line segment A, which is true. But is A longer than D? No, A is less than D. So this is not true. And so this one must be true. Line segment A is shorter than D. Yes, A is less than D. And D, which is 40, is longer than C. So we have A. A is our answer here. So that was a long one. This is a pretty tricky one. And I'm going to come back and see if there's an easier way to do this, a shortcut. But for now, we're just going to stick with that. And we're going to carry forth and move on to number 110. All right. Whoops. Erase. All right. I think that might be good enough. Well, there we go. All right. Let's get 110 over here. Uh-oh. Let's move this one to the front. Send to front. There we go. All right. So let's see. Let's examine which of these is the best answer. And again, there's a lot of problems here on the HSPT where they say, well, you got to find out. They give you some numbers or something to make sense of, and then they ask you some questions about it. And sometimes the best way to do it is just to rule things out. Sometimes the best thing to do is to do all the calculation. In this case, I think we can figure out these answers pretty quickly ourselves. So one of the key things in math is to remember that of means multiply. So if I say 50% of 10, I mean 50% times 10. So that's point number one. Point number two is that percents are easy to convert to decimals. So let's solve all of these problems knowing that it's easy to convert percents to decimals, and we can turn ofs into multiplication signs. So let's do that for all three of these questions. And we can do that hopefully pretty quickly. Again, we want to be solving all of these problems in about a minute if we can, because that's about the rate at which we have time for on the HSPT. So the first thing is 100% of 95. Well, that's actually a pretty straightforward problem, but we'll work it out knowing what we know about of and percents. So to convert a percent into a number, we just move we take the percent and we move the decimal 2 to the left. So 100% is the same as a 1, right? It's a 1. Because we take that 100, we move the decimal 2 to the left, and we get a 1. Of means multiply, and then we have the number 95. So 1 times 95 is just 95. Now let's stop and look at that. And we should know, or many of us know, that 100% of something means all of something. If you give 100% effort, that's all of your effort. No more, no less. So 100% of 95 is just 95. 100% of a million is a million. 100% of 5 is 5, because 100% means all of something. So that makes sense. So the first number is 95. 100% of 195%. So let's look at that. 100% times 195%. Well, that's 100% is 1, remember, because we move our decimal twice. And 195% is 1.95. 1 times 1.95 is 1.95. So that's 1.95. And 95% of 100 is 95% times 100 is equal to 0.95 times 100. And if you multiply that out, 190, that's equal to 95. And a couple of ways to do that. If you multiply, well, first of all, we can just take our 0.95 and multiply it by 100 and get 0.050, and then we get 0.009, 9500, and we have two numbers after our decimal, and so we can get our 95 that way. But another way to do it is if you ever multiply a decimal by 10 or 100, you just multiplying, say, 0.95 times 10, you just move the decimal once. And so that would be 9.5. 0.95 times 100 means you move the decimal twice. So that equals 95. So a couple ways you could get 95. So that's 95. Now that we know our three numbers, we can answer the questions. Well, is B greater than A? Well, no, that's not true. C is greater than A plus B. Well, no, 95 is not greater than 95 plus 1.95. A and C are equal and are greater than B. Well, we know that that one's true. Yes. Check. That one's true. And then, so this must not be true. A and C are equal. That's true. And are smaller than B. Well, that's not true because B is only 195. So there's the answer there. And we will move on. Here, let's just kind of erase all this. Erase, erase, erase. We'll just erase all this. And we'll move, and we'll move on to 195. Let's see. And we're going to, whoops. We're going to send this to the front. Wow, unbelievable. What am I doing? Butterflies. Let's go back. Let's forget about these butterflies and let's just take this guy and move it, let's see. Send to front. There we go. That's kind of what I expected to happen. Oh my goodness. I'm going to have to do some erasing here of these butterflies. Sometimes the unexpected happens in Mr. Lipscomb's videos, and Mr. Lipscomb doesn't even know what's going on. Okay. And there we go. How many sixths are there in 4/5? I don't even understand how to think about this problem. This is crazy. So I'm going to think about this. I know this is a division problem, but let me ask this a different way, and let's apply the knowledge to solving this problem. So let's say, let me ask the question, let me use numbers that I know and not use these fractions, right? So let's go, how many 2's are there in 10? This is an easy question. I know how to do this one. How many 2's are there in 10? Well, the way I find that, I know there's 5 of them. I know there's 5. I don't even have to think about that. Well, how did I do that? How many 2's are in 10? Well, that's a division problem. That's 10 divided by 2 equals 5. Well, let's just make sure that works again. You take that second number divided by that first number. Let's ask it a different way. How many 3's are there in 12? Well, I know that there's 4. And so it's that second number divided by that first number. All right, now that I see the pattern, I can say, wow, how many 6's are there in a 4/5? Oh, I know how to do that. Well, that's the second thing divided by the first thing. And again, I really encourage you, if you get stuck in these stupid problems that are asking you like this, no one's ever going to ask you this question in real life, but in math at HSPT, and maybe on the SAT someday they will. One way to do it is to just use easier numbers that you know how to answer and then find the pattern and then solve. So this is the second number divided by the first number. And this is a problem that we know how to solve. To turn a division problem into a multiplication problem, we just take 4/5 and we turn that into a multiplication problem by inverting the second number, right? We know this is true. You invert and multiply is how you turn a division problem into a multiplication problem. And that is equal to 24/5. And if we want to turn that into the simplest form, turn it into a mixed number, we get 4 4/5. Okay, good. Moving right along. Let's not do any more of those butterfly patterns. Let's see if we can just get problem 198 knocked out. Yeah, let's just erase this whole thing. And then let's go this thing, and let's send this to the front. Uh-oh, not that thing again. That silly butterfly thing. Let's do this. Uh-oh, what am I doing? Okay, send to front. Okay. Oh, all right. I love this problem. Let's get this one sorted out. So we have this number line, and it's asking us this question of AB union. This is a, so, all right. So U means union. And union means, okay, and then union means the kind of like, it means adding two geometric shapes together. That's one thing. That's one thing it can mean. So union means, you know, taking this and that, and then figuring out what you get when you put them together. So AB is this piece. This line segment AB is this thing. So if you take that thing right there, yeah, let's make it nice and thick, and you union it with BC like this. Oops. What do you get? If you get this AB and you union it with BC, you get this line that goes from A to C. That's all they're asking here. They're basically trying to figure out if you understand this notation, if you've been introduced to the union notation. And so if you take that AB piece and add it to BC, what line do you get? Well, you get a line that goes from A to C. And that's all they're asking here. Let me ask you a different question, and I'll give you the answer just so you can get the other half of this problem, because they may ask you this too on the test. So if you have a line ABCD, and they'll say maybe what is AC intersect BD? What this means is they want the common piece. What is common among these two lines? So let's look at that, and that would be AC. If I took line AC and I intersect it with line BD, what is the common piece here? And the common piece, if for those of you can see close attention, this is the common piece. This piece right here, because BC, AC, and BD, these lines share this common piece, and that goes from B to C. So AC union BD would equal this. So you may, again, I'm just telling you this because these two symbols, U means union. Well, in that means intersection. Okay. And all right, we're going to move on now to 208. Why does it keep doing that to me? Let's see, this one. want this one moved sent to front. All right, and now I want to erase everything else. Erase. And then we'll move on to 222, and then we will be done. Okay, in order to increase revenues, a municipality considers raising its sales tax from 5% to 8%. How much more will it cost to buy a whoa, look at that, a $250 television set if the 8% sales tax is approved? Okay, well, let's see. How much is, I'll say we have a so the cost of an item is equal to its, its original cost plus the tax. And tax is usually expressed, expressed as percentage. Okay. So in this case, a television set would cost, so let's say before raising tax, the cost is equal to the original cost of $250 plus 5% of $250. Okay, and so let's work on that. Remember how we did percents and ofs and what that meant. Well, the cost would be $250 plus 5% is 0.05, and you can go back to the earlier explanation of why, but 5% is also 0.05, 10% is 0.1, 25% 0.25. We'll just do it. 5%. We have to move to go from percent to a number. We have to move a decimal twice. So we had 5, and we have to go once, and we have this 0 here, and we're going to move past the 0, and so we get 0.05. Of is multiplication, and then 250 is 250. So to figure out that tax, we say, well, 0.05 times 250, and we go, well, 5 times 0 is 0, 5, carry your 2, 5 and 2 is about 12. So our tax is $12.50. So the original cost is $250 plus $12.50 in tax. Now I'm just going to leave it like this, and you'll see why. We could have added it together, but I'm just going to leave it like that for a second. And let's go on and figure out what our cost is cost after raising tax. Well, the cost is equal to the same as before, with the exception of being 250 plus 8% of 250, because we raised that tax to 8%. So now we have 8% of 250, and we have to figure out, well, what's 8% of 250? Well, that's 0.08 times 250. 8 times 0 is 0. 8 times 4 is 0, carrier 4. 8 times 2 is 16, carrier plus 4 is 20. So that's $20 is our tax. So now our cost is equal to $250 plus $20. So that's our new cost. So you can maybe see why I didn't bother adding them together, because I'm going to compare this original cost to our new cost. And we can tell that if we raised it, if this was our original cost and this is our new cost, then we actually raised it $7.50, because the difference between $12.50 and $20 is 20 minus $12.50. And that's equal to, well, we go 1991. Whoops, I don't need to do that second one. That's 0, that's a 9. Sorry, that's a 10. 5, 750. Yeah, there's our 750. And so the answer is indeed A, 750. Okay, we're going to move on to the last problem. Hopefully this has been helpful so far. Hopefully you've taken the time to pause the video, try some of these out. If things didn't make sense, you've slowed it down. Let's now go and select our last problem. Why does it do this? Why does it do this? Okay, I'm just going to do this. I'm going to say File, New, Create, and then paste. Wait just a second. Let's just do it like this. There we go. There we go. Okay, so we have a problem here where we're trying to evaluate what R equals if we know what N equals. So let's write this in. And let's just say, well, R is equal to 35 minus 3 plus 6 times negative N. Wow. And we know that N is equal to 2. Well, let's simplify this a bit. I know that 3 plus 6 is 9, so I can just first of all start off and say R is equal to 35 minus 9 times negative N. Well, I can simplify this further because I know that negative 9 times negative N is R equals 35 plus 9N. And now I'm going to take this N equals 2 and plug it in here. And I'll say R is equal to 35 plus 9 times 2 equals 35 plus 18 equals 53. So our answer is 35. I can see what the person who worked this problem before did, and they got confused on their negative signs. But the best thing to do, I think, is to remember that when they were simplifying, probably the first thing to do is right at this step is to see that 3 plus 6 can be simplified into 9. And then the second thing is really key is that when we have this negative here and this negative here, that those things, when you multiply that out, you're going to end up with a positive 9N. Another route you could have taken right at this point, I'm gonna show it to you a different way. Is you could have said, well, this is 9 times negative N. And you could have said R equals 35 minus 9 times negative N, which would be negative 9N. And subtracting a negative is the same thing as adding a positive, so you'd still end up with 35 plus 9N, and then you'd be right back here. I kind of did a couple steps in one to go from here to here, but regardless, you're going to end up with getting rid of that double negative and turning it into a positive. All right. Well, hopefully this was useful for you. I did work those problems. Maybe I worked some of them a little quickly. Take the opportunity. Oh, where did my glasses go? Take the opportunity to look through some of those problems. Feel free to send me any questions you might have. cowboy.lipscomb@gmail.com. I'd be happy to answer them for you. Otherwise, I, again, hope this was useful, and I will, wait a minute, what's going on here? What's going on here? What's going on? That's what I was waiting. That's what I was waiting for. All right. Good night.